I just wanted to make a short video explaining how some of the terms in the second order polynomial, what they kind of mean and why they're useful to have. Okay, so here's the example. I do this through an example. So imagine we're in the two-dimensional case in the sense that there's two features, and the features are the following. x1, which describes the amount of rainfall in a farm. Okay, so we're considering the case where we're farmers for some reason, and x1 describes how much rainfall we have on the farm in inches. x2 is the feature that describes the amount of fertilizer that we use on the farm, and this is described in grams. Okay, and y, the label, the thing we're trying to predict, is the profit of a farm based on these two features. Okay. And now suppose this is the true underlying kind of relationship of these features and the profit of a farm. So I'm giving you this, and this shouldn't feel too contrived. And then what I'm going to claim is if you want to model this, you're going to want polynomial terms. Okay. So here it is. It's suppose that when there is a lot of rainfall, right, when you have more rainfall, the same amount of fertilizer becomes more effective. Okay, so this is the claim. And this should make sense. You get more rainfall, the fertilizer becomes more effective. And more precisely, I want to give you a mathematical relationship, which is that, so this precisely part, so for every inch of rain that increases, right, a rainfall increase, every gram of fertilizer produces $10 more. Okay? So that's the relationship. And that should also be reasonable, right? This is just putting the above claim into mathematical terms. Rain increases, then every gram of fertilizer you already applied produces $10 more of profit. So the way you would model this is through the following relationship, which is you would write this function, your predictor, would need to depend on x1 and x2, the two features. But it would have to depend in this way, in this multiplicative way. And notice that this thing is an element of second order polynomial. So it would be an element of f2. Okay? It is not an element of f1. This is really a second order polynomial. This term comes from phi of 2. Okay, and why is this the correct relationship? Well, we can just see this through a couple case, like a kind of a case study. So imagine we've already applied 2 grams of fertilizer. So x2 is fixed at the value of 2. Now let's think about what happens if we change the rainfall. So here it says that we start first at 0 rainfall, right? What does that imply? That implies from our model here that it's 10 times 0 times 2, and this will give us 0 profit. So you get no profit when there's no rainfall. Basically, you get no growth of your crops. However, if the rainfall increases to 1 inch, the claim here is now, since you have applied 2 grams of fertilizer, right? And since for every inch increase in rain, the information we are given is that the fertilizer produces $10 more, we see that we are now producing $20. Okay, so we have 2 grams of fertilizer, we increase the rainfall by 1 inch. Each gram of fertilizer gives us $10 more, so we get a total of $20. Now, suppose the rainfall increases even further. And here, you can see how this depends on the amount of fertilizer. We still have 2 grams of fertilizer. However, what we have is that since the rainfall increased from 1 to 2, that's 1 inch increase, for each gram of this fertilizer we have, we get $10 more. So now our profit is 40. So it goes from 20 to 40. So we have this relationship where increasing rainfall, which is this feature, depends, you can have this relation like this dependence on how much fertilizer you apply. Okay, and finally I want to show this graphically. So on the right, this plot is what is the model and the predictor that we've just discussed. So you can see when we have 0 rainfall, you're gaining no profit, right? This z-axis here is the amount of profit. You have no profit. No matter the fertilizer you apply, I don't care, you get 0 profit. Now, let's imagine we increase the rainfall to 1. Okay, so let's fix some amount of fertilizer. Say we look at the 2 case, so maybe we're somewhere here. If we increase the rainfall to 1, what we'll see is that our fertilizer becomes more effective. Then if we increase the rainfall further to 2, which is what we saw, it becomes more effective, and so on and so on. But notice that this really depends on how much fertilizer we applied. In the case where we applied like 5 grams of fertilizer, we notice that increasing the rainfall would increase to like $50 in this case, right? It would be 5 for every gram of fertilizer. 1 inch increase in rainfall would increase in $10. So you go 5 to 50, then to something like 100, then to 150, all the way to 200, and then 250. So the gain in terms of your profit really does have this relationship between fertilizer and rainfall. And this is in contrast to a different model. This would be the model that only has the following terms. This is the function on the left. So this one only has linear relationships between x1 and x2. And here you're stuck with this thing where x1 cannot depend on x2 and vice versa. x2 can't depend on x1. And what this means is for 0 amount of rainfall, you might have some increase in fertilizer. And in general, for any amount of fertilizer, like for instance 3 or 4 or 5, you always have to have the same slope in terms of how the rainfall affects it. Because the rainfall is always just this additive term. It cannot depend on x1 without this polynomial cross term, the x1 times x2 term. Okay, so what that means is, yeah, like you have 5 grams of fertilizer, you have 1 gram of fertilizer, or whatever, you have to write that the rainfall increasing actually helps you. And in the extreme case, you can see if you have 0 grams of fertilizer here, you still would end up with rainfall being modeled as increasing your profit, even though you didn't even apply any fertilizer. And in that case, let's say the crops wouldn't grow at all. And that's because you have this thing, this term increasing here, or sorry, this term here for the rainfall increasing, while this is set to 0. And so you can see that the trouble of using this kind of model. Okay, so hopefully this clarifies the value of having this type of term in a second degree polynomial. And here I've only talked about the x1 times x2 term. Of course, there's also this x1 squared and x2 squared terms, which I didn't discuss here, but I just wanted to highlight what is the use of having this. And if you have higher order polynomials, you can even have more complicated relationships between like x1 times x2 times x3, and so on and so on. I will end here.